Fourth grade, lesson 2.7 is multiply using partial products. Again, this is letting your brain kind of understand what's going on with the expanded form, pulling that over in our partial products over into the standard algorithm you will use, but helping your brain make sense of why we multiply the way we do, why we use the algorithm we do. So these past few lessons are just slowly building up to the standard algorithm you will use to multiply with multiple digit numbers. And so let's go ahead and have a look at how the next step goes.
Okay, a quick look at our essential question. How can you use place value and partial products to multiply by a one-digit number? So we'll unlock the problem. How can you use what you know about the distributive property to break apart numbers to find products of three-digit and one-digit numbers? The multiplication, an answer to a multiplication problem, is a product. So the answer to a three-digit and a one-digit number. Well, recall that how do we write 182 as a sum of hundreds, tens, and ones? Again, that's kind of your expanded form, right? We would do 100 plus 80 plus 2. That's what they mean by writing it as a sum of hundreds, tens, and ones, is the expanded form, 100 plus 80 plus 2. When you add those together, the sum will be 182. And so that is what they've done here. They have the 100, they have the 80, and they have the 2. And they have this in picture form with us and the beginnings of the algorithm that you will normally use when you multiply after we've taught you all the pieces that fall into that place. Because it's confusing to learn without the pieces falling into place. It still can be learned that way, but it's a little more confusing because our brains don't understand, why am I doing this step? It doesn't make sense. So this is just taking us there so that our brains can make sense of what's happening. So they estimated first, right? We have 6. Round this is to the greatest place value. This would be 200. Hopefully that's becoming much more quick for you now. 200. And 6 times 200 would be 1,200. So we know our answer should be somewhere around 1,200. We rounded up. It was 182. We rounded it up to 200. So this is a little higher than our answer is going to be. All right. Just like in the previous lesson, we're going to take this knowledge. We have 182 times 6. We lined up this way, but we're just going to do the 6 times the 1, which is representing this part, the 6 times the 100. It's 1 in the hundreds place. So we'll do the 6 times 100. 6 times 1 is 6, and we get 600. Then we're going to move over, and we're going to do the 6 times the 8 in the tens place, which is 80, this part. 6 times 8 is 48. If you don't have that memorized, use your grid to help you with that until it does get memorized. Again, work on memorizing your multiplication facts and have them memorized before the end of this year. 6 times 8 is 48 with a 0 on the end. That's going to be 480. This one was 600. I'm going to go ahead and write that there. So I will write 480 here and try to line that up. Then I will look at this part right here. This is 6 times 2. 6 times 2 in the ones place, and 6 times 2 is 12. And then I will add those all together, all of it all together. So 0 plus 0 plus 2 is 2, 8 plus 1 is 9, 6 plus 4 is 10. My answer comes out to 1,092. So 6 times 182 equals 1,092. Since 1,092 is close to the estimate of 1,200, it is reasonable. That was our estimate. We knew it was going to be below that because we had rounded up. So it would be below 1,200, and it was just a little below 1,200, close to 1,100. Okay, let's look at some more examples so this clicks all into place. This is taking us closer to the standard algorithm you will use for multiplication. Here is another example. We'll use place value and partial products to multiply 2 times 4,572. So we have it set up in the standard way you will eventually multiply it. It will be similar to this. There's a slight change. You'll see why later. But it will be similar, very similar to this. You'll set it up this way. And they went ahead and estimated so we could know, are we getting a reasonable answer. So 4,572 rounded to the nearest place. Next number is a 5, so this is going to be about 5,000. It's, between 4,000 and 5,000 is what this number is. Closer to 5,000 is a 4,000, barely. 2 times 5,000, well, 2 times 5 is 10, with 3 zeros on the end. Our answer should be somewhere around 10,000, but a little less than that, right? Because we rounded up from here to there. So a little less than 10,000 is what our answer should be. I should make that look more like a 10,000. I don't know, that looks like a P or something. There we go. Now it doesn't look like a letter. All right. And they don't have our boxes drawn. If that box is drawn helps you, we could use that. But we have 4,000 plus 500 plus 70 plus 2 is this number in expanded form. I'll draw the box in case it helps you. And we're going to use the distributive property to do the 2 times 4,000 first. 2 times 4,000, that's 2 times 4, which is 8 thousands. So 2 times 4 thousands is 2 times 4 thousands, or 8 thousands. So we're going to go ahead and put the 8,000 here. That took care of this part here. Distributive property to do 2 times 500. That is 2 times 5 hundreds in words. 2 times 5 is 10. So 10 hundreds is 1,000, right? We did 2 times 5 is 10, and then the hundreds zeros there. That's how that happened. 1,000. I should write this as the numbers. I'm going to change this to be the number 8,000. Okay, now we have the 2 times 70. So we will do 2 times 7 tens. 2 times 7 is 14 tens. 2 times 7 is 14 with the 1 0 on the end. And we get 140. And finally, we do the ones column. 2 times 2 is 4. And then we just add all of those together. Using the addition, the algorithm for addition that we always use. 4 plus 0 plus 0 plus 0 is 4. 0 plus 0 plus 4 is 4. 0 plus 0 plus 1 is 1, and 8 plus 1 is 9. Our answer comes out to 9,144. So 2 times 4,572 is 9,144, which is a little below the 10,000 estimate like we expected. That answer is reasonable. All right, so hopefully it's starting to click into place. We're at a good stage for you to practice and pause it. Pause and try. Play to see where you get stuck, or play to see if you got it correct. So we're going to do these practice problems together in that way. Pause it when you want to try it. Play it when you want to check it. We're going to use the model this time. The box is to find 2 times 137. We're also using the beginnings of our standard algorithm over here to do that both ways. That way you can take this knowledge and place it in over here. So they split up 137 to 100 plus 30 plus 7. And then we use the distributive property 2 times 100, which is what they're doing here, 2 times 100, and that is 200. Then we use, I'm going to put those arrows there, distributive property there, distributive property here. We're going to do 2 times 30. 2 times 3 is 6, and the 0 makes that 60. And then we use the distributive property again. 2 times 7 is 14. And then all we need to do is add those together. 0 plus 0 is 4, plus 4 is 4. 0 plus 6 is 6, plus 1 more is 7. And 2 plus nothing is 2. Our answer is 274. Is that reasonable? This would round to about 100. It's between 100 and 200. 2 times 100 is 200. We rounded down, though, so it should be higher than 200, and it is. So that's reasonable. Okay. Let's go ahead and do the estimate on this one. This would round to about 200, right? We have the 1 here. That 9 makes it go up. This becomes 200 times 3. 200 times 3 is going to give us 600. So our answer should be really close to 600 because this is very close to 200. It's just going to be a little bit under 600 probably because we rounded up. we're going to go ahead and break these apart, and maybe we don't need our boxes anymore, but in our minds we can say, all right, we have 3 times 100, 3 times 90, and then we don't have to worry about the 0. It'll be 0. 3 times 0 is 0, right? So 3 times 100 is going to give us 300. 3 times 90 is going to be, 9 times 3 is 27 with a 0 on the end, is going to be 270. And 3 times 0 is 0. We add all of that together, and our answer is 670. And my brain's saying, wait, didn't I say 600? And it was going to be a little below, and look, I ended up with 670. So suddenly that estimate is going to be that stop sign for my brain, like, wait, I think something's wrong. And you probably noticed it. I didn't. I actually made this mistake. I multiplied these instead of added this. This is 3 plus 2, not 3 times 2. Do you see that? So I wouldn't have caught that mistake if I hadn't done the estimate first. I would have thought, okay, 670 is the answer, moving on. But because we had estimated, and I had even mentioned, all right, this answer is going to be a little bit below that, not by much, right? And then I ended up with 670. I was like, that doesn't seem right. So that helped me catch my mistake. The answer is 570. All right, let's have a look at this next one. Number 3 is 471 times 4. 471, if I were to round it to the greatest value, I look at the neighbor, it's an up number. This is going to be closer to 500. So we know the numbers between 400 and 500, and it's closer to 500. That's why we're rounding it to that. So we're going to call that, oh, that's not what we're going to call it. It's 500 times 4. 500 times 4. 4 times 5 is 20 with 2 zeros on the end. 2,000 will be our estimate. We rounded up, so it's not going to be as high as 2,000. It will be just below 2,000. Good to know in case I make another error, right? Okay, we're going to start with the 400, and I'll write this out in case our brains are not quite catching it. That's okay. We got to be patient with our brains, right? And we're going to do 4 times that, so you could see the distributive property happening. This is 400 plus 70 plus 1, and we're multiplying all of those expanded form times 4. So we'll do 4 times 400. Well, 4 times 4 is 16 with the 2 zeros on the end. 4 times 7 is 14 with the 1 0 on the end. Correction. And 4 times 1 is 4. Add those all together. 6, 7, and 1. 1,744 is a little bit lower than 2,000. That answer is reasonable. 1,744 is the answer I get there. Let me make sure to make that look a little more clear. Okay. Let's look at the final one. Again, try it, see how you do, and push play when you're ready to check it, or if you get stuck. This is a safe way to make errors. Nobody knows you made the error. Nobody knows you got stuck, right? Okay. My estimate. I'm going to look at this. This is a 3. It's going to be between 3,000 and 4,000. This number, it's closer to 3,000 than it is to 4,000 because this next number is lower than a 5. So I'm going to round this to 3,000 in my head. And based on everything that we have been doing with that partial products, 7 times 3 thousands is 7 times 3 is 21,000. My answer is going to be 21,000. Well, near 21,000, I should say. Estimates are ish or near. Now, I rounded down, right? So there's more to this number than the 3,000. So my answer is going to be above 21,000 a little bit. That's how it should be. Let's split this up. If you feel like you are understanding that I'm taking the 7 times 3,000 and then the 7 times 400 and then the 7 times 30 and then the 7 times 9 and putting them in rows, go ahead and do that. If you need to see the expanded form, I'm going to go ahead and give that to you here. So 3,439 is broken up to 3,000 plus 400 plus 30 plus 9, and we're going to multiply all of those by 7. We'll use the distributive property to do that. 7 times 3,000, well, that's 7 times 3, which is 21. 21,000. Then we will do 7 times 400, which is 7 times 4, which is 28, with 2 zeros on the end, 2,800. Then we will do 7 times 30, that's 7 times 3 tens. 7 times 3 is 21 tens. And finally, 7 times 9. Oh, I forgot to put this. It's 210. 7 times 9. That may not be memorized yet, or it might be. Hopefully it is. But the 7s, 6 sevens, and 8s, or 9s are the ones that take longest to memorize, in my opinion. 7 times 9, in case you don't know, is 63. You can use your chart. 63. I will add those all together. 0 plus 0 plus 0 plus 3 is 3. 1 plus 6 is 7. 8 plus 2 is 10. 1 plus 1 is 2 plus 2 is 4. And 2 plus nothing is 2. I ended up with 24,073. 24,073 is the answer I ended up with. And yes, it is a little more than 21,000, just like we said it would be. I hope this was making sense to you. This might be one that you want a little more practice with me on before you go on to Think Central to make sure you've got this solid. You do want to have this solid so that when we take the next step into the standard algorithm or towards the standard algorithm, everything is falling into place. So if you feel like it's solid, you can go ahead and go on Think Central and do the problems by yourself. If you are still wanting a few more practice problems with me, wait, and we will work on a few more together in class.